Good morning, ladies and gentlemen. May I have your attention, please? Thanks. Let's go ahead and get started on our Bellwork. We know that we can calculate a series, right, a sum of individual terms by using the individual terms and summing them together. If it's a particular category of sequence, then oftentimes we have formulas to make our job easier. So what I want you to do is go ahead and tell me the general formula for the sum of a finite number of terms if your series is arithmetic. So for number one, we have an arithmetic series. We can sum those terms up by using my formula for a finite sum, S of n. And what does that look like with a's? With a's and n's, right? No numbers, just with a's and n's. What would that look like? Danny?
A sub 1 plus A sub n in parentheses times n divided by 2.
Awesome. And right there, if you use the same formula, you recognize it as arithmetic. Awesome, great. Okay, so let's go ahead and plug in our first term then. When n equals 3, I know the value of my first term will give my 4 minus 2/3 times 3. So that looks like 4 minus 2. So is my first term 2 for a sub 1? Awesome. Plus my nth term in this case is the 9th term. And so a sub 9 will be given by 4 minus 2/3 times 9 will be 4 minus 6, right? And 4 minus 6 is a negative 2. How many terms are in the sequence? Well, I always do top index minus bottom index, 9 minus 3 plus the first one. So that would be 7. We get 7 for that. Yeah. Killing it. All over 2. And we can even do this without a calculator. 2 plus a negative 2 is 0 times 7 is 0. All over 2 is 0. Raise your hand if you have 0 for number 1. If you have 0 for your finite sum, awesome. That's pretty sweet. What type of sequence is represented in number 2? So what type of sequence is represented in number 2? Vivian? Geometric. And since it's a finite sum, we also have a formula for that. We know that my finite sum, S of n, is given by, and go ahead and tell me without numbers, but with G's and N's and R's, what would that look like as a formula? Sydney?
G sub 1 times parentheses 1 minus R dot parentheses over 1 minus R.
Awesome, thank you. We can see my constant multiplier, R, right, is 2/3. And my first term, even though this says G sub 1, in this formula that represents my value of the first term in the sum. So I still use 3 to do that. And then I can just plug in to my formula and evaluate the finite sum. Let's go ahead and do that. So 3 in for n, 2/3 to the third power, right? 2/3 to the third power is going to be 8/27. Is that right? 8/27. Yeah? Anytime I want to calculate now, I'm 4, so 32/37. Yikes. Sorry, 32/27. Yes? Times 1 minus 2/3 to the, and what are we going to do for our n here? Right? What are we going to do for our n here? Well, we've got 9 minus 3, so again, 7. Are you guys using 7 for that? All over. 1 minus R would be 1 minus 2/3. I think now is a great time to go to the emulator. So one like this would be on the calculated aloud portion of the test. I would certainly leave number 1 open to being on part 1, non-calculator, or part 2. Yes? You should know the formulas, however, regardless of which part you're on. So you should know these formulas for finite sum of arithmetic, geometric, and then infinite sum for geometric. Why did I say infinite sum for arithmetic? Because I forgot? No. Yeah, arithmetic sequences the sum of an arithmetic sequence, right? If it's infinite, does not exist, the series does not exist, it diverges. All right, so what do we need here? We just need a home screen. Come on, Mr. Fritz, we need a 32/27. We need a 1 minus 2/3. Uh-oh. equals 7. We're okay. Close top. Divided by open bottom. 1 minus 2/3. Let's take a minute and see how many times I messed up the parentheses there. We're okay? We're okay. And survey says, raise your hand if you had 3.347. 3.347? Yes! That's great news. So about 3.347. But with all those fractions, I bet, right? I bet this is rational as well. So if I did a math frac, nope, no go. Too much? Too tough to change? Let's take a look at our third one. So, what formula will we use to calculate the infinite sum, right, for the series in number 3? What formula will we use for that? Vivian?
There is no formula.
Yeah, there is no formula. How come, Emily?
Because of some divergence.
Yeah, absolutely. So, there's no sum, no infinite sum, because it's an arithmetic sequence. We know those always diverge. Awesome. Raise your hand if you had number 3, diverging. Diverging because it's arithmetic, and you should be able to provide a reason for that. Lastly, number 4, by golly, we've already seen the terms were geometric in nature. The question is, does this infinite sum converge or diverge? Riley?
Converges
It converges. How come?
because R is less than 1.
Absolutely. Our ratio R, 2/3, is less than 1. Therefore, this will converge. All right, what will it converge to? Well, we have a formula for that. Tyler?
G sub 1 over 1 minus R.
Awesome. That's even simpler than my partial sums formula. Or sorry, finite sum formula. G sub 1 again is just whatever the first term with the first index here, the lower index. So I put in 3. We already did that. 2/3 cubed is 8/27 times 4 is 32/27. And that's all over 1 minus ratio R is 2/3. And I don't know. We already kind of did, right? 32/27 divided by quantity 1 minus 2/3. Is it going to be close to that, I wonder? Close to our original answer already? So 3.5. Now I'm going with the math frac. Yes! 32/9. Raise your hand if you got 32/9. 32/9. Hey, way to go, you guys. Awesome. And that is exact. Great. What question do you guys have on your Bellwork? So our new thing in this unit was series, right? Sequences and series. I'm going to go ahead and pause during our homework collection.